Good morning, good afternoon, or good evening, depending upon where you live around the world. In the previous videos, I was making comment about how I am now contemplating cutting some of the pipe for the dome project into lineal strips, and they can then act as my interface plates on the inside of the pipe. Now, for those that are following along with the efforts to get all the bugs out of the design or the approach, you'll recognise this perhaps as one of the steel hubs. And 83 millimeters long, 114 millimeters in diameter, 5 millimeters thick. So it is a stout little pipe, not unlike myself, short and thick. But we wanted to be able to cut it into 25 millimeter wide strips, 25 or 30. It's the figure's arbitrary, and I wanted them to be done easily, obviously, and accurately. I thought, well, how do we do that? And I made the comment, oh, well, you just make a jig. Well, of course you do. So I thought, hang on, I better go make said jig, or at least draw it up. So that's what I've got here. This is a bit of 50 by 25, as is this, a couple hundred millimeters long, and I've joined them together and then put some 45 degree angle fillets on this jig to locate the hub itself. Now, it would probably pay to have these two fillets, these 45 degree fillets, positioned so it just lifts the hub off of the timber here. It stops any chance of interference and causing misalignment. Not super critical, but probably prudent. So all we've done is got have these two 50 by 25 or whatever. They could be half that thickness, arbitrary, but they're spaced by about 1 to 1.5 millimeters, because that's the thickness of this cutting disc. Now, if you're not using these cutting discs, I suggest you start, because the difference is huge compared to the old discs that we once used. They quite often say this is a cutting disc for stainless steel. Regardless, a lot of people use them now. The one downside to them, however, is that they're quite fragile and they do not like taking abuse at all. So wear your safety gear and have your guards on your grinder, otherwise you could regret it. So safety warning out of the way. We can move the grinder. It's 125 millimeter, 115 some of them, 125 is the one I've got. So it's a relatively small grinder, and we can score backwards and forwards until we're almost through, or at least leave a tab so that the pipe doesn't collapse, or when we rotate it the amount that we want, we can keep on doing that cutting almost all the way through, so the pipe stays together, so it allows you better control of the pipe and therefore the grinding. So that was a really easy way of doing it. I've done something very similar to this, not on this heavier pipe, but I've done something very similar to this, and it works very well. And then once we're almost all the way through, we can finish off just by hand, hold this or clamp it, and just finish off the last couple of millimeter of steel that needs cutting through. So you've got the strips of this ready to go, and then they can be thrown onto the bench sander and the inside diameter flatted, so that we have a nice mating surface for our nuts or bolts or washers. So that was simple. And then I thought, we also need to drill accurately the holes in the pipe. Now at the moment I'm saying that the holes in the hub should be the same height on all of the hubs. I think that's prudent. So that being accepted, we can then say, well, in my case, come up 15 millimeters from the block, which will become used as a registration block for the end of the pipe. So 15 millimeters and then 65 or 50 mil gap in between, and that will allow us to spot drill, emphasizing the spot, the marks or positions on the hub. That way we're not putting our our metal drill a bit through the hole at all, even though the spot drill is a twist drill. I'll explain a little bit more in a moment. So that way we can rotate it round with the marks already marked on the pipe from our paper template, which I've touched on and explained a little bit previously. So we can rotate it, eyeball it, or have a jig marked something, spot it with the spotting drill, and then we can take it out and put it in the drill press and drill it properly. Now that's going to allow us to keep the two holes dead in line with each other, and they're going to be the same distance on all of the hubs. Even if the hubs are slightly different in height by a mil or two, if we line it up on one end, I'm suggesting the bottom, then they all have a consistency or uniformity of measurement and hopefully accuracy. So there we've got our hole drilled in it and aligned. Now these spotting drills that I mentioned was something that I'd never even heard of before, and I would have said to use a center drill for said purpose because they're such a, well, they seem to be designed for it. But while yes, and I probably will still use the center drills for this purpose, I saw a video talking about a spotting drill. So I had to, of course, go have a look at it, didn't I? And the ordinary metal drilling twist drills, twist bits, are ground at 118 degrees for their tip, but the spotting drill is at 120, and that 2-degree difference in the grind means that the spotting drill creates a spot mark on the steel that's at a slightly different angle. That means that the 118 degree grind will touch the edge of the surface, not of the hole or the spot, not the center. And therein lays part of the problem of using a center drill, because that will have the same degree angle grind as the twist drill, whereas the spotting drill just being a little bit flatter means that it aligns better the twist drill when you go to drill it, and you don't get that tiny but sometimes annoying little wobble when you're trying to align things. So that was news to me. If it's news to you, go chase down the YouTube video. I didn't keep the link or anything for it, but just type in something in the search of YouTube, spotting drills or versus centering drills or something like that, and you'll be fine. So this is a jig for cutting the strips of pipe. This is a jig for spotting the points on the pipe or tube for the bolts or screws to go through. Now, I prepared this earlier. This was the attempt I thought about in a similar vein, that the part of the assembly that we want for the threaded rod and pipe is to either have a half round pipe, or a full one. And I thought, well, what would be better than having a block that has been drilled to the diameter of the pipe so it can be inserted, and a 90-degree hole can be positioned so that it can drill the holes through the pipe. because if you do that, you can drill right through the pipe and have the two holes align, and importantly on the tangent point of the outer circumference, outer surface of the pipe. That's important because you may, if you just say have a jig like this and drill down with your drill press, be ever so slightly offline, or as the drill is going through, this can kick and rotate slightly so that the line, the hole rather, while possibly still in line with each other, may be canted to one side. How do I know? Been there, done that. Very annoying. So this little block can align my hole correctly on that surface and line drill it. Or let's just, before I go there, the drill that created that hole can be inserted into the chuck. Let's just back up a little bit. I'm getting ahead of myself. I rotate this round 90 degrees. 90 degrees, David. Excuse me. If I wanted, for some reason, and I didn't have a pipe, but I had a solid piece of rod in there, and I wanted a dead center hole in it, something that I've attempted to do before, and I wound up getting a friend with a lathe to do it. But if I want to do that in my drill press, I make a block like this, drill the diameter of the rod, and then when I come to drill my hole in the end of the rod, I can reinsert the drill for this hole, roll down the chuck and the bit to realign with this block, and then clamp the block off, because that is then perfectly centered for then inserting the rod and changing the bits to the, say, the 3mm steel bit that I want, and then drill dead center of the rod. When I saw that, I thought, oh my goodness, how logical and simple is that? And it is. So I didn't hold on to the URL for that, because when you see it you go, oh, that's obvious, but it's only obvious in hindsight. So that's a really good way of recentering your block that you may have to use on occasion, and realigning it, as it were. And then I thought, that would work for if I were to have my rod or pipe in my V block in my drill press. A very similar approach can be had, where you make sure that when you make the block, you have a line, you align the hole dead center of the V. And that way, when you come to put your pipe in place, and pretend this is a drill now, all I've had to do is to put this in the chuck, wind the chuck down to reinsert into the hole, clamp the block, then take that out if it's not the correct diameter hole, drill for the hole that you want to draw, and it might not be, and then put my pipe or rod in place, and then with the correct drill bit, drill down, and that will give me the correct tangent point right on the crest of the outer surface of the pipe. And again, I thought that was just so darn logical. Doesn't matter whether the alignment drill is bigger than the hole you want, it just gives you that realignment. In fact, what I would suggest is you find a drill and a piece of rod, like I've used the shafts that came out of a inkjet printer that I pulled apart, and they've got some very, very precision ground rods as the bearings or the rollers, and I use that for my alignment. So if I can find the correct drill, make a very tidy hole in the timber or the steel, and then I can refer back to that piece of rod to insert into the drill. The reason I actually started using that was actually for a similar reason, but I wanted to align my drill perfectly flat for drilling horizontally, and I use those rods that you probably look into the opening of your printer, and you'll see it with a solid shaft with wee rubber rollers on it, and it's beautifully polished or chromed or whatever it is, finished, and it's very rigid. So it allowed me the chance to insert that rod into the drill chuck, meant that it wasn't wobbling around. It's a precision piece of engineering in that rod, and allowed me to get my measurements correct for getting the height for my then drill to drill into the side of things horizontally. So that was, but that's the same logic if you use your steel bit to align it, or just use your bit that you use to drill the hole, whatever. So that allows for repeatability and accuracy for doing these sorts of things. I actually did a couple of these experiments on a very small bit of aluminium tube, and I was amazed. I lucked in and I got them to align perfectly, and I was feeling quite impressed with myself. Went to do another set, damn things didn't align properly. They're ever so slightly out. This would go a long way to remedying that problem. The other the other thing was, if you want to drill through your steel pipe after you've spotted it, of course, with the spotting drill, and you wanted to do so at a particular angle, V-block, nest that into the V-block, and you cut your wedge on your miter saw, or your say you've got a sled for your bench saw, you can cut your wedge at whatever angle you darn well like, slip it underneath and drill through. So if I wanted a 13.5 degree angle off of vertical, I create that angle wedge there and I have at it. Very, very simple. And again, once everything is aligned, it may, in something like this, and this is where I was chewing over this idea, and I said, well, that works if you can get your drill in, etc. But this means that I can align better further away than, I don't have to move the head of, you perhaps have done this yourself, you try to line something and then you realise that you have to move the base of the drill, the work surface of it, and you realise, oh, no, not aligned anymore. But that's where that rod comes in, that long rod, because the one I was using out of the Canon printer was 300 millimeters long or so. So that allows me a lot of fiddle room to be able to stick it in, align my jig, and then take it out and put my drill in, and I'm still at the point where I can drill through my pipe. But this was an idea for angling the screws so that when they come through they'd go on an angle, which I have kind of relegated to not absolutely necessary, and it may well be better to, it may be okay to do that, but to drill it square and then get one of those the drill bits that cut on the edges, on the sides, they're more toys than anything, but put that in and then you can angle the pipe a little bit to just slog it out onto an angle, whatever. That's up to you. I'm just throwing it into the mix because it popped into my head at the time. those strips that I was mentioning in the previous from the previous example that could be used, these strips here, they replace the section of pipe here that would also be radiused on this edge here. So what that has done and has allowed is that those strips of tube, as I was just indicating, is thinner than this is. So you'd have to go back and look at the video. I won't load it on this particular video, but needless to say, it's nicer to have a nice solid piece of steel in place that is thinner than this to stop the bulking up of the threaded rods and nuts. So that's another plus for having these strips of the steel tube over this. But there may be a time that comes that this is appropriate type of thing to use. And the main claim to fame was that you can rotate the end of through the hole, an oversized hole. This stays in place, your screw can angle up and down, and the head can find its resting point on the different tangent points or surface of this tube. But then I went backwards in time and I cut a wedge shaped square washer, say a 25 by 25 mil square with a 10-degree angle on it, and I made up a little block, so easy as it turned out, and I did it. I thought, well, that therefore gets away from this and takes me back in time to a previous version of making those interfaces. Why am I saying this when I'm not actually showing it? It's to say that if you can make something more betterer, more elegant and efficient, then it behooves you to have a look at that. And doing away with a slight complexity is probably not a bad thing, because I could almost guarantee it, when it comes time to assemble the things, simple will pay for itself over and over again, whereas fiddly will drive you nuts. Okay, that's it. I'm off. Have to have my third cup of tea, and I will see you in another video. Okay, bye now.